Hi, I'm Rob. Welcome to Math Antics. In this lesson, we're going to learn about mixed numbers and how they relate to improper fractions. Mixed numbers. I love mixed numbers. So full of protein and vitamins. You want some? Those are mixed nuts, and no thanks. I'm trying to explain mixed numbers. Oh, mixed numbers. You mean like when I get a whole bunch of numbers and put them in a bag and shake it up, pull out one to see who wins? You want to play? That's a raffle, and that's not what mathematicians mean when they say mixed numbers. Well, you sure are hard to please today. As I was saying, we're going to learn how mixed numbers relate to improper fractions. But first, we need to make sure that you understand what an improper fraction really is. To do that, let's start with a short number line that counts whole numbers from 0 to 3. And let's subdivide the spaces in between each whole number into 4 equal parts, or fourths. So a block this size represents the amount 1, because it covers the distance from 0 to 1. While a block this size represents the fractional amount 1/4, because it only covers the distance from 0 to the first subdivision that we made, which is 1 out of 4, or 1/4. But suppose we add another fourth to the fourth we already have. That would give us 2/4. And adding another fourth would give us 3/4. And adding another fourth would give us 4/4. What's 4/4? Yep, it's what I like to call a whole fraction, because its value equals 1 whole. Oh, and by the way, we're going to be using the term whole fraction a lot in this video. It's not an official math term, so your teacher might not use it. But just remember that whenever I say whole fraction, I'm talking about any fraction that has the exact same number on the top and on the bottom. 2 over 2, 8 over 8, 100 over 100, those are all what I call whole fractions. Since all whole fractions equal 1, you can replace any whole fraction with 1. And you can replace 1 with any whole fraction. And you can see how that works on our number line. The 4/4 all combine to cover the same distance as 1. The fraction 4 over 4 is equivalent to 1, and vice versa. But now, what if we get a little crazy and add one more fourth? Now we have 5/4, and we've gone past 1 on the number line. 5/4, or 5 over 4, is what we call an improper fraction, because the numerator, the top number, is greater than the denominator, the bottom number. That means its value is greater than 1. In this particular case, how much greater than 1 is it? Well, on the number line, we've gone past 1 by the fractional amount 1/4. So 5/4 turns out to be equivalent to 1 and 1/4. Have a good look at this diagram for a minute, because it shows us something really important about how proper fractions, improper fractions, whole fractions, and mixed numbers all relate to each other. First, on this side of the number line, we have 5/4, which we know is an improper fraction. But notice how we got it. We added a proper fraction to a whole fraction. When we just had 4/4, we had a whole fraction. But when we added one more fourth, it became the improper fraction 5 over 4. So one way to think of an improper fraction is that it's a combination of one or more whole fractions and a proper fraction. That's helpful because we know that all whole fractions can be simplified to the whole number 1. And if we did that, we'd get what's shown on the other side of the number line. We'd get the combination of the whole number 1 and the proper fraction 1/4. In other words, we'd get a mixed number. That's all a mixed number is. It's the sum of a whole number and a proper fraction. It's an alternate way to write an improper fraction where all the whole fractions that are inside the improper fraction have been simplified out into a whole number. To help that sink in, let's look at another improper fraction, 8 over 3, or 8/3. We'll use the same number line that goes from 0 to 3, but this time, let's subdivide each whole number into 3 parts to make counting thirds easier. So this would be 1/3, this is 2/3, and this is 3/3. Oh, there's a whole fraction already. Let's make note of that while we continue adding thirds. Next we have 4/3, 5/3, 6/3. Oh, we just formed another group of 3/3. That would equal a whole fraction also. Let's note that and continue. 7/3 and 8/3. As we noted, 8/3 actually contain 2 whole fractions. Each of those whole fractions simplifies to 1. So that means our mixed number form would have 1 plus 1, or 2, as the whole number part. And then the fraction that's left over after simplifying all the whole fractions is 2/3. So the improper fraction, 8/3, is equivalent to the mixed number 2 2/3. Pretty cool, huh? And to show you that you can go back and forth between these two forms, check this out. In the mixed number 2 2/3, the whole number 2 and the fraction 2/3 are being added together. That's really important to know, even though the plus sign isn't usually shown. So 2 2/3 is really 2 plus 2/3. And if we wanted to, we could expand the 2 into 1 plus 1, right? That gives us 1 plus 1 plus 2/3. And then we could replace each of those ones with the whole fraction 3/3, since 3/3 equals 1. That gives us 3/3 plus 2/3. Since these fractions all have the same denominator, we can add them easily. The denominator of the answer will stay the same, 3, and the numerator will be the sum of the other numerators. 3 plus 3 plus 2 equals 8. And there we are, back to our original improper fraction, 8/3. You can convert any mixed number into an improper fraction using that procedure. You can change the whole number part into a sum of whole fractions and then add everything up. For example, 2 1/8 could be changed into 8/8 plus 8/8 plus 1/8, which all add up to 17/8. And 3 4/5 could be changed to 5/5 plus 5/5 plus 5/5 plus 4/5, which all add up to 19/5. And 4 2/3 can be changed to 3/3 plus 3/3 plus 3/3 plus 3/3 plus 2/3, which all adds up to 14/3. Notice that we always chose whole fractions with the same denominator of the fraction part of the mixed number, so that they're all like fractions that can be added easily. And some of you might see the shortcut here. In each case, did you notice how many of the whole fractions we needed to add together? Yep, it's the same as the whole number part of the mixed number. If it's 2, then we need to add 2 whole fractions. If it's 3, we need to add 3 whole fractions. If it's 4, we need to add 4 whole fractions, and so on. The whole number tells us how many times to repeat the addition. And since multiplication is repeated addition, we can multiply instead of adding. 2 times 8/8 gives us 16/8, and then we add that result to 1/8 to get 17/8. 3 times 5/5 gives us 15/5, and then we add that result to 4/5 to get 19/5. 4 times 3/3 gives us 12/3, and then we add that result to 2/3 to get 14/3. That shortcut really helps when the whole number part of the mixed number is big. Like, what if we needed to convert the mixed number 15 1/4 into an improper fraction? Instead of having to add 15 whole fractions together, we can just multiply 15 by the whole fraction 4/4, which gives us 60/4. Then we add that result to the fraction 1/4 to get 61/4. That's the improper fraction form of 15 1/4. All right then, but what if we need to go the other way? What if we start with an improper fraction and need to convert it into a mixed number? Well, whenever we have an improper fraction, we know there's at least one whole fraction hiding in there that we could simplify out. The question is, how many? To see what I mean, let's try converting the improper fraction 7/2 into a mixed number using a little trial and error. First, let's try subtracting out just one whole fraction. 7/2 minus 2/2 equals 5/2. That means we can write 7/2 as the mixed number 1 and 5/2, since we subtracted out one whole fraction and had 5/2 left over. And even though that's true, it's bad form because 5/2 is still an improper fraction, which means that there's at least one more whole fraction hiding in there that we could have subtracted out. So let's try again, but this time let's subtract out 2 whole fractions. 7/2 minus 2/2 minus 2/2 equals 3/2. That means we could write 7/2 as the mixed number 2 and 3/2, since we subtracted out 2 whole fractions and had 3/2 left over. But that's still bad form because the fraction part is still improper. We could have subtracted out another whole fraction. So let's try again, subtracting 3 whole fractions this time. 7/2 minus 2/2 minus 2/2 minus 2/2 equals 1/2. That means we could write 7/2 as the mixed number 3 1/2, since we subtracted out 3 whole fractions and had 1/2 left over. And that's the proper mixed number form of 7/2 because it's a whole number and a proper fraction. So there's no more whole fractions that we could simplify out. That process makes sense, but it's kind of messy having to subtract out so many whole fractions. It turns out there's a shortcut we can take here too. Just like multiplication is repeated addition, division is basically repeated subtraction. That means we can figure out how many whole fractions we can subtract out of an improper fraction by just dividing the top number by the bottom number. Let's do that with our example 7/2. If we divide 7 by 2, we find out that 2 will divide into 7 3 times, leaving a remainder of 1. That remainder is actually important, as we'll see in a minute. Notice that the answer to our division problem is exactly how many whole fractions we were able to subtract out of the improper fraction, 3. So the answer to the division tells us what the whole number part of the mixed number will be. And here's the really cool part. The remainder of the division tells us what the leftover fraction will be. The remainder is the numerator, the top number of the leftover fraction. In this case, since the remainder is 1, we'll have 1/2 left over in our mixed number. Let's do one more example to make sure you've got that. Let's convert 22/5 into a mixed number. If we divide 22 by 5, we see that 5 will go into 22 4 times with a remainder of 2. That means that the whole number part of the mixed number will be 4, and the fraction part will be 2/5, because our remainder was 2. That's how many fifths will be left over. So 22/5 is the same as 4 2/5. All right, so now you know what mixed numbers are. They're a combination of a whole number and a proper fraction. And you know that those two parts are actually being added together, even though the plus sign is usually not shown. You also know that a mixed number is basically a simplified form of an improper fraction, and that you can use the procedures we learned to convert back and forth between the two forms. But the way to make sure that you really understand mixed numbers, improper fractions, and how to convert between them is to practice. You need to do some exercises on your own and check your answers to make sure you're doing the procedures right. Oh, I'm doing it right. In fact, I found an even quicker shortcut. How's that for mixed numbers? As always, thanks for watching Math Antics, and I'll see you next time.
All right. Welcome to Math with Mr. J. In this video, I'm going to cover how to add, subtract, multiply, and divide mixed numbers. Now, I'll go through one example each, which should be helpful for anyone looking for a quick review or refresher, whether you learned this recently or years ago. If you need more help or examples, I dropped links to other videos on mixed numbers down in the description. Now we're going to start with addition. Let's jump into our example where we have 5 2/7 plus 4 2/3. Now the first thing that I'm going to do, I'm going to rewrite this problem vertically, so up and down, lining up the fractions and whole numbers. So we'll start with 5 2/7 plus 4 2/3. So once we do that, we need to find a common denominator. We're not able to add because we have a 7 and a 3 for our denominators. We need a common denominator in order to add the fractional part of these mixed numbers. So in order to find a common denominator, we need to find a least common multiple, and that's going to be our least common denominator. Now you may be able to figure out what the least common multiple between 7 and 3 is without writing out the multiples. But as a review, I'm going to come to the side here and we'll write out our multiples, and I'll show you how to find the least common multiple. And again, that's going to be our least common denominator. So let's start with 7, and I'm going to write out the first 4 multiples of 7. Now, the multiples go on forever, so my suggestion, write 4 or 5. See if you have any in common. If not, you can always extend your lists. So 7, 14, 21, 28. Now we'll write the first four multiples of 3. So 3, 6, 9, 12. And we don't have any matches there. We don't have anything in common. So let's extend our lists. Now 7, we're already at 28. And for our multiples of 3, we're only at 12. So let's extend that list. So then we have 15, 18, still nothing in common. And then we have 21. So 21 is going to be our least common multiple, and therefore our least common denominator. So that's what we're going to use. So once we have that common denominator, we're going to rename the fractional part of our mixed numbers with that common denominator. That way we'll be able to add. So let's go over to our mixed numbers here and rename. We do not need to do anything with the whole numbers. So this is going to be 21. So let's use equivalent fractions to rename that 2/7 with a denominator of 21. So we need to think, how do we get 7 to equal 21? Well, 7 times 3 is 21. Whatever we do to the bottom, we must do to the top in order to keep this equivalent. 2 times 3 is 6. So 6/21 is equivalent to 2/7. We're not changing the value of the problem at all. These are equivalent fractions. We're just renaming using that common denominator. Let's bring the addition sign over, and then we need to do 4 2/3. Again, we do not need to do anything with the whole number, and we have a common denominator of 21. So let's think, how do we get 3 to equal 21? Well, 3 times 7 is 21. Whatever we do to the bottom, we must do to the top in order to keep this equivalent. So 2 times 7 is 14. So now we're ready to add. To recap, we found our common denominator of 21. Then we renamed the fractions of our mixed numbers using that common denominator of 21. Now that we have a common denominator between our fractions, we're able to add. So let's add our fractions and then whole numbers. So for our fractions, add the numerators. 6 plus 14 is 20. And then we keep our denominator of 21. So 6/21 plus 14/21 equals 20/21. So we added our fractions. Now let's add the whole numbers. So 5 plus 4 is 9. So our final answer is 9 20/21. Always check to see if you can simplify the fractional part of a mixed number. Well, 20/21 is in simplest form. The only common factor between 20 and 21 is 1. So we are done. And our final answer is 9 20/21. Next, let's move on to subtraction. So for our subtraction example, we have 9 3/4 minus 2 2/8. Now the first thing that I'm going to do is rewrite this problem vertically, so up and down. And I'm going to line up my whole numbers and fractions. So let's come to the side here, and we'll do 9 3/4 minus 2 2/8. So what I'm going to do, I'm going to subtract the fractions first and then the whole numbers. Now when we subtract fractions, we need a common denominator. So as we have the problem written out now, we have a denominator of 4 and a denominator of 8. So we can't subtract quite yet. We need to find a common denominator and rename. We find a common denominator by looking for common multiples, and then the least common multiple we can use for our least common denominator. So let's write out our multiples of 4 and 8. Now you may be able to do this, figure out what the least common multiple is without writing out the multiples, but I'll write them out as a review. So the multiples of 4, well, let's count up by 4, 4, 8, 12, 16. Now those multiples go on forever. So my suggestion Write out 4 or 5. See if you have any in common. If not, you can always extend your lists. Now let's write out 4 multiples of 8. So we have 8, 16, 24, 32. Once we have that, we can look for the least common multiple, which is going to be the smallest number in value that they share, which is going to be 8. So 8 is going to be our least common denominator. Now that we have the common denominator that we're going to use, we can rename the fractional part of these mixed numbers with that common denominator of 8. So let's start with 9 and 3/4. So this equals, keep our whole number the same, and then we need that common denominator of 8. So let's use equivalent fractions here. 4 times 2 equals 8. Now whatever we do to the bottom, we must do to the top in order to keep this equivalent. So 3 times 2 gives us 6. 6/8 is equivalent to 3/4. We're not changing the value of the problem at all. We're just using equivalent fractions to rename that fraction with our common denominator. So let's do 2 and 2/8 now. We'll put our subtraction sign there. Now 2 and 2/8, that already has a denominator of 8. So we do not need to do anything with that mixed number, and specifically the fraction. Again, because we already have that denominator of 8. Now that we renamed what we needed to rename, we have a common denominator of 8, and we're able to subtract. So let's subtract the fractions of these mixed numbers. So 6/8 minus 2/8. Subtract the numerators, 6 minus 2. That gives us 4. And then we keep our common denominator of 8. Once we have that, we can subtract the whole numbers. So 9 minus 2 gives us 7. So we get 7 and 4/8. Always look to see if you can simplify the fractional part of a mixed number. We can. 4/8 can be simplified. We have a greatest common factor of 4. So let's divide both of these by 4. And we get 7. 4 divided by 4 is 1. 8 divided by 4 is 2. So we get a simplified answer of 7.5. So we've gone through an addition and a subtraction example. Now we'll move on to multiplication. For our multiplication example, we have 4.5 times 2 and 3/5. Now the first thing that we want to do is to convert our mixed numbers to improper fractions. That way we have a numerator and a denominator, and we can multiply straight across. So in order to do this, we start at the bottom. So let's start at the bottom here, and we work our way to the top. We multiply, then add. So we do 2 times 4, our denominator times the whole number. So 2 times 4 is 8 plus our numerator of 1. That gives us 9. So again, 2 times 4 is 8 plus 1 gives us 9. That's the numerator of our improper fraction. We keep our denominator of 2 the same. Now that improper fraction is equivalent to our mixed number. They're just in different forms. We're not changing the value of the problem at all when we convert to an improper fraction. Let's bring our multiplication sign down and then convert our other mixed number. So we multiply, then add. So 5 times 2 is 10, plus 3 gives us 13. That's our numerator. And then keep our denominator of 5 the same. Once we have our mixed numbers converted to improper fractions, we can multiply straight across. So numerator times numerator and denominator times denominator. Let's start with the numerators. So 9 times 13, that gives us 117. And then 2 times 5 gives us 10. So that's our answer as an improper fraction, 117 tenths. Now let's convert that to a mixed number. We do that by dividing our numerator, 117, by 10. Now we can either do this using mental math or writing out the division problem to the side. I'll do both here. So 117 divided by 10, how many whole groups of 10 can we pull out of 117? Well, 11. That gets us to 110. We don't hit 117 exactly, so we have something left over, a remainder. So the difference between 110 and 117 is 7. That's what's left over. That's our numerator. And then keep our denominator of 10 the same. Now, if you're unable to do that using mental math, you can always come to the side and write out the division problem. So, for example, we'll start with how many whole groups of 10 out of 11? 1. 1 times 10 is 10. Subtract, we get 1. Bring down the 7. So how many whole groups of 10 out of 17? 1. 1 times 10 is 10. Subtract, and we get a remainder of 7. So we get the same thing either way. Sometimes problems are a little more friendly and we can do them using mental math. Sometimes we may need to write out the division problem. Either way works. So just to recap how we converted from an improper fraction to that mixed number, we did 117, the numerator, divided by 10, the denominator. So how many whole groups of 10 out of 117? 11. Then we have a remainder of 7, which is our numerator, and we keep our denominator of 10 the same. Always check to see if you can simplify the fractional part of a mixed number. Well, 7/10 is in simplest form. The only common factor between 7 and 10 is 1. So this is in simplest form, and we are done. 11 and 7/10. Lastly, let's move on to division. So for our division example, we have 4 and 3/4 divided by 2 and 1/3. Now, the first thing that we want to do is to convert these mixed numbers to improper fractions. That way we just have a numerator and a denominator. Let's start with 4 and 3/4. And we start at the bottom and work our way to the top. So we multiply, then add. So we do 4 times 4, so the denominator times the whole number. 4 times 4 is 16. Then we add the numerator. 16 plus 3 is 19. So 19 is the numerator of our improper fraction. We keep our denominator of 4 the same. Then we can bring our division sign down and convert our second mixed number. So again, we multiply, then add. So 3 times 2 is 6, plus 1 is 7. That's our numerator, and then keep the denominator of 3 the same, so 7/3. 19/4 is equivalent to 4 and 3/4, and then 7/3 is equivalent to 2 and 1/3. So we're not changing the value of the problem at all when we convert to improper fractions. Mixed numbers and improper fractions are equivalent, they're just in different forms. Now again, we're converting to improper fractions, so we just have a numerator and a denominator, and then we can go through our steps for dividing these fractions, which we're going to use keep, switch, flip, also known as keep, change, flip. So no matter how you think of it, they mean the same thing. I know there's different words out there for these steps, but in the end, they all mean the same thing. So let's keep our first fraction here, our first improper fraction, so 19/4. Then we switch or change our division to multiplication, and then we flip our second fraction, our second improper fraction here. So the denominator becomes the numerator, and the numerator becomes the denominator. This is called the reciprocal. So we have 3/7. Once we get to this point, we can multiply straight across. So numerator times numerator, and then denominator times denominator. Let's do the numerators first. So 19 times 3, that gives us 57. And then we have 4 times 7, which is 28. Now that's our answer as an improper fraction. We're going to convert it to a mixed number. So we need to do our numerator, 57, divided by our denominator, 28. Now we can do this using mental math, or we can write everything out. Some problems are going to be a little simpler and we're going to be able to use mental math, and in some situations we'll have to write out the problem. I'll go through both here so you can see what that looks like. Let's use mental math here first. So how many whole groups of 28 out of 57? Well, if you're able to think about that, it's going to be 2 whole groups of 28 because that gets us to 56. So 2 whole groups of 28. Now we do not hit 57 exactly. We have something left over, a remainder. So the difference between 57 and 56 is 1. So we have a remainder of 1. And we keep our denominator of 28 the same. Let me write that out as well. So we have 57 divided by 28. So we need to think how many whole groups of 28 out of 57. Well, we said that's 2. That gets us to 56. So 2 times 28 is 56. So we get a remainder of 1. This 2 is going to be the whole number, part of our mixed number, 2 whole 28s out of 57. And then this 1, the remainder, is going to be the numerator. And then we keep our denominator of 28 the same. Once we get to our mixed number, we can check to see if we can simplify the fractional part. 1/28 is in simplest form. The only common factor between 1 and 28 is 1. So we are done. 2 and 1/28. So there you have it. There's a review of how to add, subtract, multiply, and divide mixed numbers.
Hi, I'm Rob. Welcome to Math Antics. In this lesson, we're going to learn how to add mixed numbers. If you're not quite sure what mixed numbers are, then you should definitely watch our video called Mixed Numbers first. As you remember, a mixed number is a combination or sum of a whole number and a proper fraction. And for this lesson, it's going to be important to remember that even though the plus symbol isn't usually shown between those two parts of a mixed number, they're being added together. 3 1/4 means 3 plus 1/4. 2 5/8 means 2 plus 5/8. And here's why that's so important to remember. Let's say you're given a problem where you need to add the whole number 2 to the mixed number 3 1/4. If you know that 3 1/4 is the same as 3 plus 1/4, then you can see that the problem is really 2 plus 3 plus 1/4. Well, that's easy. All you have to do is add the 2 and the 3 to get 5, and you'll have 5 plus 1/4, which is the mixed number 5 1/4. So if you need to add a whole number to a mixed number, you can just add the whole number parts and you're done. Okay, but what if you need to add a mixed number to a fraction, like in the problem 1 3/8 plus 1/8? Again, if you remember that 1 3/8 means 1 plus 3/8, then you can see that this problem is really 1 plus 3/8 plus 1/8. That looks pretty easy also. 3/8 and 1/8 are what we call like fractions. They have the same denominator and can be added easily. 3/8 plus 1/8 equals 4/8. So our answer is simply the mixed number 1 4/8. Oh, but you might notice the fraction part can be simplified. 4/8 simplifies to 1/2. So we should write our answer as 1 1/2 instead. It's not mathematically wrong if you don't simplify a fraction, but teachers and tests usually require you to simplify whenever you can. So it's a good habit to get into. Notice that in each of those examples, we just added whole numbers to whole numbers and fractions to fractions. And it works the same way when adding a mixed number to a mixed number, like 2 1/5 plus 4 2/5. Again, let's show our mixed numbers with the plus signs so we can see the real problem. 2 plus 1/5 plus 4 plus 2/5. Because all of these parts are being added and addition has the commutative property, it really doesn't matter what order we do the addition in. That means we can rearrange this problem to make it simpler. Now we have 2 plus 4 plus 1/5 plus 2/5. Adding the whole numbers is easy. 2 plus 4 equals 6. And adding these like fractions is easy too. 1/5 plus 2/5 equals 3/5. That leaves us with 6 plus 3/5, which is the mixed number 6 3/5. So when you add mixed numbers, you can just add the whole number parts to get the whole number of the answer. And you add the fraction parts to get the fraction part of the answer. That's why in a lot of math books, you'll see the addition of mixed numbers written in a stacked form like this. This is similar to the way you would stack multi-digit numbers up to add them. And it helps you remember that you can add the fraction parts and the whole number parts in two separate columns and write your answer below the answer line just like in multi-digit addition. And do you remember how in multi-digit addition, if a column of digits added up to 10 or more, you had to carry or regroup to the next column? Well, something similar to that can happen when adding mixed numbers. Sometimes adding the fraction parts of two mixed numbers actually affects the whole number part of the answer. To see what I mean by that, let's say you hosted a massive pizza party for all your friends. Hey man, this is a great party. You got some really cool friends. Hey, thanks. You should hang out with us more often. I think you'd really fit in. And after the party ended, you had 1 3/8 cheese pizzas left over and 1 5/8 pepperoni pizzas left over. What's the total amount of leftover pizza? Well, we just need to add those two mixed numbers together. Stack them like I just showed you and add them column by column. 3/8 plus 5/8 equals 8/8. And 1 plus 1 equals 2. So the answer is 2 8/8. But do you see what happened? The fraction parts of the two mixed numbers combined to form what I call a whole fraction, 8/8. And we know that 8/8 simplifies to 1. So having 2 plus 8/8 is the same as having 2 plus 1, which is 3. We added two mixed numbers together and ended up with the whole number 3. And our leftover pizza shows us that we got the answer right. Here's another example that shows how the fraction parts can affect the whole number part of the answer when adding mixed numbers. 1 3/7 plus 2 5/7. This time we'll use the commutative property to rearrange the addition, and then we add the whole number parts. 1 plus 2 equals 3, and then we'll add the fraction parts. 3/7 plus 5/7 equals 8/7. So the answer we get is 3 8/7. But do you notice something funny about the fraction part of that answer? It's an improper fraction, which means that its value is greater than 1. And it's really bad form to leave an improper fraction in a mixed number like this, because as we saw in the last video, the improper fraction itself can be converted into a mixed number. 8/7 contains a whole fraction that we can simplify out of it. It's the same as 7/7 plus 1/7. And since 7/7 equals 1, that gives us the mixed number 1 1/7. So just like in the last example, we can add that extra 1 to the whole number part of our answer, which gives us 4 1/7. That's a much less confusing answer than 3 8/7, which almost sounds like it's less than 4, but it's actually more than 4. Are you getting it so far? Adding mixed numbers is pretty easy when you realize that you can just add the whole number parts and the fraction parts separately, and then just watch for cases where the fraction parts add up to more than 1. But there are cases where adding mixed numbers can get a little bit tougher. All of the examples we've seen so far had fraction parts that were like fractions. But what if you had to add two mixed numbers with unlike fractions, like this problem, 1 1/2 plus 2 1/4? If we rearrange the problem as usual, we see that the whole numbers are still easy to add. 1 plus 2 equals 3. But the fractions have different denominators. We can't add them until we change them so that the bottom numbers are the same. We cover how to change fractions so that they have the same bottom number, or a common denominator, in other videos that you may want to watch if the steps I'm about to do seem new to you. 4 is a multiple of 2, so 4 is going to be a good choice for a common denominator. To change 1/2 into fourths, we'll multiply it by the whole fraction 2/2. On the top, we have 1 times 2, which is 2, and on the bottom, we have 2 times 2, which is 4, just like we want. So now we have 2/4 plus 1/4, which equals 3/4. That means the answer to this problem is 3 3/4. That wasn't so bad after all. Let's try one more example where we need to change unlike fractions into like fractions in order to add the mixed numbers. 3 2/3 plus 4 3/4. After rearranging the parts, we see that we need to add 3 and 4, which is 7. And we also need to add 2/3 and 3/4. Since these are unlike fractions, we need to change them. 3 and 4 are not multiples of each other, so it looks like using the easiest common denominator will be our best option here. 3 times 4 equals 12, so that will be our new denominator. To convert 2/3, we multiply it by 4/4, which gives us the new equivalent fraction, 8/12. And to convert 3/4, we need to multiply it by 3 over 3, which gives us the new equivalent fraction, 9 over 12. Now that we have like fractions, we can add them easily. 8 over 12 plus 9 over 12 equals 17 over 12. That gives us 7 and 17/12 as our answer. But once again, the fraction part is improper, so we have to simplify it because its value is greater than 1. 17 over 12 is the same as 12 over 12 plus 5 over 12, which is the mixed number 1 and 5/12. We need to add that 1 to our whole number part. 7 plus 1 equals 8, which means our final answer is 8 and 5/12. All right, that should give you a pretty good idea of how to add mixed numbers. You can add the whole number parts and the fraction part separately, but the fraction part of the answer may affect the whole number part if its value is 1 or greater. And remember, if the fraction parts have different denominators, you'll need to change them to have a common denominator before you can add them. With complicated arithmetic like this, it's important to practice what you've learned so it'll really make sense. So be sure to try some exercises.
All right, and we've got.
Hi, I'm Rob. Welcome to Math Antics. In our previous lesson, we learned how to add mixed numbers. And in this lesson, we're going to learn how to subtract them. Subtraction is always a little trickier than addition because subtraction does not have the commutative property. That means that the order of the numbers you're subtracting matters, and you can't switch it like you can with addition. Subtraction is also tricky because if you try subtracting a number from a smaller number, like 1 minus 5, you get a negative answer. Fortunately, we're not going to cover any problems that give negative answers in this video. But as you'll see in a few minutes, there are cases where it seems like you need to subtract a bigger number from a smaller one at first. All of this means that subtracting mixed numbers can be quite a bit more complicated than adding them. But don't worry, we'll take it one step at a time. And it'll help a lot if you make sure that you have a good understanding of topics like adding mixed numbers, subtracting fractions, order of operations, and multi-digit subtraction, because this lesson built on all of those concepts. Okay, to see why subtracting mixed numbers is trickier than adding them, let's have a look at two problems side by side. 5 plus 2 1/3 and 5 minus 2 1/3. We learned how to do problems like the first one in the previous video about adding mixed numbers. Since 2 1/3 just means 2 plus 1/3, we learned that we could rewrite the problem like this and simply add up the whole number parts to get the whole number part of the answer. 5 plus 2 is 7, so the answer mixed numbers is trickier than adding them. Let's have a look at two problems side by side. 5 plus 2 1/3 and 5 minus 2 1/3. We learned how to do problems like the first one in the previous video about adding mixed numbers. Since 2 1/3 just means 2 plus 1/3, we learned that we could rewrite the problem like this and simply add up the whole number parts to get the whole number part of the answer. 5 plus 2 is 7, so the answer is 7 1/3. But if we try to do the same thing with subtraction, we're going to get the wrong answer. If we rewrite 2 1/3 as 2 plus 1/3, it looks like we could just subtract the whole numbers. 5 minus 2 is 3, which leaves 3 plus 1/3, or 3 1/3, as the answer. But it turns out that's not correct. So what did we do? Well, when we subtract a mixed number, we need to subtract the entire mixed number. We need to subtract the whole number part, and we need to subtract the fraction part. But we didn't subtract the 1/3, we added it. That's because when we rewrote the mixed number as a sum of a whole number and a fraction, we forgot, or we didn't realize, that they form a group. We just put the 2 plus 1/3 right after the minus sign, and it made it look like we should subtract the 2 and add the 1/3. But we actually should have subtracted both of them. One way to avoid that mistake is to use parentheses around the mixed number you're subtracting so you remember that its parts form a group, and you need to apply the minus sign to the whole group. And you can only get rid of the parentheses after you apply or distribute the subtraction to each member of the group, like this, minus 2 minus 1/3. Now that we have the problem written correctly, we'll get the right answer if we do these math operations. Going from left to right, we have 5 minus 2, which is 3. But then for the last step, we need to subtract 1/3 from 3. That might seem hard to do unless you remember what we learned about whole fractions in the last video. When adding mixed numbers, sometimes we'd get an answer like this, 2 3/3. But since 3/3 is what I call a whole fraction, its value is just 1. And we learned that we could simplify an answer like that. 2 3/3 is 2 plus 1, which is 3. Well, how about if we just do that same process in reverse? Instead of simplifying, let's unsimplify. We're trying to take 1/3 away from 3, right? So let's rewrite 3 as 2 plus 1, and then let's rewrite 2 plus 1 as 2 plus 3 over 3. Does the problem look easier to do now? We converted part of the whole number into the whole fraction, 3 over 3, and we already know how to subtract fractions. 3 over 3 minus 1 over 3 is 2 over 3. So that means our final answer is 2 2/3. So as you can see, subtracting mixed numbers can be a little complicated, but not all problems are that hard. Some are pretty easy, like this one, 6 4/5 minus 1 3/5. We still need to remember that the mixed numbers form groups, so we have to subtract both parts. But that's where the stacked format that we learned about in the last video can really help us out. Since the order of a subtraction problem is important, we need to be sure to put the mixed number that we're starting with on top, and the mixed number that we're taking away on the bottom. And doing that helps us remember that both parts of a mixed number are being subtracted, even if we don't put parentheses around them to remind us. That's because we'll subtract the parts column by column, just like we would in multi-digit subtraction. We'll subtract the fraction on the bottom from the fraction on the top, and then we'll subtract the whole number on the bottom from the whole number on the top. 4/5 minus 3/5 is 1/5, and 6 minus 1 is 5. So the answer is just 5 1/5. See, that really was easy. And that's why I recommend using stack form whenever you can for subtracting mixed numbers. It'll help you remember that both parts of a mixed number are being subtracted without having to worry about groups or parentheses. But even though the stacked form is a great way to keep from getting confused about groups, it doesn't make every problem quite that simple. For example, let's try the problem 5 1/7 minus 2 3/7, and let's use stack form. We're starting out with 5 1/7, so it goes on top, and 2 3/7 goes on the bottom. But when we try to subtract the fractions column, you'll see that we have a little problem. 1/7 is less than 3/7, so we can't subtract it without getting a negative number, which we'd really like to avoid. So what do we do now? Well, do you remember what you do in multi-digit subtraction when you have to subtract a bigger digit from a smaller one? Yep, you borrow or regroup from the column to the left. And we can do something really similar to that with mixed numbers. We can make the fraction part of a mixed number bigger by borrowing from the whole number part. In the video about adding mixed numbers, we learned that a mixed number with a fraction part that's improper is bad form, because you can simplify out a whole fraction and then add it to the whole number part. Well, we can do that process in reverse also. We can subtract out 1 as a whole fraction from the whole number part and add it to the fraction part to get an improper fraction. And even though that's considered bad form, it's okay because it's not our final answer. And it helps us subtract the fraction column without getting a negative fraction. In this example, we do that by changing the whole number part, 5, into 4 plus 1, and then changing 4 plus 1 into 4 plus 7 over 7. And finally, we can combine that 7 over 7 with the 1 over 7 to get 8 over 7. Now the fraction on top is big enough to subtract 3 over 7 from. 8 over 7 minus 3 over 7 is 5 over 7. And then we just need to subtract the whole number parts. The top whole number used to be 5, but we borrowed from it, so now it's 4. 4 minus 2 equals 2, so our answer is 2 5/7. Let's try another example to make sure you've got it. And let's make it a story problem this time. Suppose there's this guy who's a builder named Rob, and suppose he needs to fix something by subtracting the mixed number 1 5/8 from 6 1/8. Can he fix it? Yes, I can. Well, at least with the help of my trusty cat, Richard. Where did that rascal run off to? Richard? Richard? Oh, well. The first thing we need to do is put these in stacked form, with the number I'm taking away on the bottom. Then I need to subtract the fractions. But I notice that the fraction on top is less than the fraction on the bottom. So I need to make the fraction on top bigger by borrowing from the whole number part. I can replace the 6 with 5 plus 1, and I can replace 5 plus 1 with 5 plus 8 over 8 to get the whole fraction I need to add to the top fraction. 8 over 8 plus 1 over 8 is 9 over 8. So now I can subtract the fraction column because the fraction on top is bigger. 9 over 8 minus 5 over 8 is 4 over 8. And then I can subtract the whole numbers. 5 minus 1 is 4, so the answer is 4 4/8. Does that look right to you, Richard? You're right. 4/8 can simplify to 1/2. So my final answer is 4 1/2. Thanks for your help, Richard. Good job, Rob, the builder. So now you know how to subtract mixed numbers. Some problems will be easy, like our second example, where you can just subtract the fraction parts and the whole number parts. But in other problems, you may need to borrow or regroup using that unsimplifying procedure. And remember that the stacked form is a great way to keep everything straight. Of course, you may also need to solve problems where the mixed numbers have unlike fractions, and you'll need to change them into like fractions before you can subtract. But that works the same way as you saw in the last video, so you already know how to handle that. I know I'm always saying it, but that's because it's true. The way to really learn math is to practice by doing some problems on your own. As always, thanks for watching Math Antics, and I'll see you next time.
Okay, those are our videos. I have that it's 10:26. We're going to take a break for 10 minutes. So let's come back at 10:40. It's actually 14 minutes. We'll come back at 10:40. All right, I've got that it's 8:40 or 10:40, so let's get started back. All right, so something you need to add to your notes: the definition of a mixed number and the definition of an improper fraction. A mixed number is a number that has a whole number part and a fraction part. An improper fraction is a fraction where the numerator is greater than the denominator. Okay. When I taught high school math back in the 1900s, and I taught my students about improper fractions, we talked about the fact that when the numerator is smaller than the denominator, like if you have the number 3/4, that a fraction was actually very strong. The bottom number, if it's bigger, was strong enough to hold up the number on the top. But when you put a larger number on the top, the 3 is weaker than the 10, and so this fraction wants to fall apart. It wants to crash because the number on the bottom is not strong enough to hold up that number on the top. And so that's why we typically don't leave answers as improper fractions, because it's bad form. We just don't write that. We change improper fractions into mixed numbers. All right. Now, the process for changing an improper fraction into a mixed number Okay, so if I have 10/3, we take the number on the bottom, the denominator, and we divide into the numerator. So I take 3 and I divide it into 10. So when I do the long division, 3 will go into 10 3 times. 3 times 3 is 9. We subtract and we're left with 1. So way back in elementary school, you learned that when you did long division, you wrote that if you were dividing 3 into 10, 3 would go into 10 3 times, and there would be a remainder of 1. Hopefully everybody remembers doing that back a long time ago. But what that means is that we have a whole number part of 3 and a fractional part of 1/3, because our denominator has to remain a 3. So 3 goes into 10 3 times. There's a remainder of 1, and so 10 over 3 is equal to 3 and 1/3. If you happen to have a TI-30 Smart View calculator, which you can use on the GED, there is a button that automatically converts improper fractions into mixed numbers for you. You don't have to do anything. As I have indicated in the past, those calculators are not that expensive. There's information on Blackboard about those calculators, shows you a picture of them. I'm going to start using that calculator in stuff that we do in class. They're only about $16, $18. You can get them at Office Max, Office Depot. Walmart usually does not carry them. Target, I think, has them. That way you're learning how to use that calculator so that when you go to take the math GED test, you will be more proficient with that calculator. And again, you can use that on the test. Now, if we're going to change a mixed number into an improper fraction, then we do what the math with Mr. J, he showed you how to do that. If I have 3 1/4, you take the 3 of the 4 down here, this denominator, and you multiply it by the 3. So that gives you 12. And then you add the number on the top, which is 1, and that gives you 13. So 3 1/4 is 13 fourths. 4 times 3 is 12. Add the 1 is 13. 7 4/5. 7 times 5 would be 35. Plus the 4 would be 39. So we would end up with 39 fifths. And we can see that if we went backwards, 5 into 39 will go 7 times, which is 35. 4 left over. So we are going to need that for our guided practice today. So I've just sent you a sheet. Okay, so we're going to start with number 1. Number 1 is 7 3/5, and it is asking us to convert that. So we need to convert it to an improper fraction. So when we convert, we take the 5 and multiply it by 7, which gives us 35. And then we add the number on the top, which is 3. So 7 3/5 is 38 fifths. Number 2, 6 5/8. We take the number on the bottom, we multiply it by the whole number part. 6 times 8 is 48. And then we add the numerator. And so 6 5/8 is the same as 53 eighths. Number 3 is 9 2/10. We take 10 and multiply it by 9 and get 90. Add the numerator. And so this becomes 92 tenths. But 92 tenths is not simplified. We always need to simplify. 92 is 2 times 46, and 10 is 2 times 5. So you should see that 2 goes into 10 and 2 goes into 92. If you don't know that 2 times 46 is 92, then you should have your calculator out and you should be punching in 92 divided by 2. So the 2's divide out, and we're left with 46 over 5. 46 over 5. All right, I'm going to do one more, 2 2/4. So we take 4 times 2, which is 8, and add the 2, which gives us 10 fourths. 10 fourths is not simplified because 2 will go into the top and bottom. 10 is 2 times 5. 4 is 2 times 2. And we get 5 halves. 5 halves. All right, number 5 is 6 1/9. I want you to do number 5. I want you to do number 5 and tell me what you get. Okay, so you're converting 6 1/9 into an improper fraction. All right, that's only what, 1, 2, 3, 4, 5 of you. There's 16 people in the class. All right, well, I'm going to start dropping people out. Correct answer is 55/9. 55/9. 6 times 9 is 54, plus 1 is 55. All right, look at number 6. We have 5 5/7. 5 5/7. So tell me what you get as an answer. Okay, that it? All right, last chance. All right. Yes, if we take 7 and multiply it by 5, we get 35. Then we add 5. That gives us 40 over 7. Make sure that you see that that denominator is 7. Okay. All right, we're going to skip a little bit and we're going to go down to the next section. We're going to go down to the next section. And it says they want us to convert. We want to take 113 over 12 and change it to a mixed number. So we're converting, this time, an improper fraction into a mixed number. Okay, so to do this process, we have to come over here and take 12 and divide it into 113. All right, I am not going to do all that long division. I'm going to use my calculator and take 113 divided by 12, and we get, when you take in your calculator and you punch 113 divided by 12, you get 9.41 da 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 da. So that means that 12 will go into 113 9 whole times. 9 whole times. So I need to know what is 12 times 9. Well, 12 times 9 is 108. So I'm taking 12 times 9 and getting 108. So to know what the remainder is right here, then I need to take 113 and subtract 108. So when I take 113 and I subtract 108, I get 5. So the remainder is 5. So to write the mixed number, I write 9 as my whole number part. My remainder is the numerator of the fractional part, and the denominator stays the same. So 113 twelfths is 9 and 5 twelfths. All right, that was number 1 on the second section. Let's look at number 2, 19 over 2. So I need to do 2 into 19, or 19 divided by 2. When you take your calculator and punch in 19 divided by 2, you get 9.5. That means that the whole number part is 9. Then we need to do that whole number part times the number outside, and we get 18. We subtract. 19 minus 18 is 1. So we have a remainder of 1. So 19 over 2 is 9 and 1/2. 19 over 2 is 9 and 1/2. Let's look at number 3. On number 3, we have 36 over 10. That means we need to take 10 and divide it into 36. Well, 10, we should be able to look at that and see that 10 goes into 36 3 times. 3 times 10 is 30. Then when we subtract 36 minus 30, we get 6. And so the remainder part is 6. So this gives us 3 and 6 tenths. 3 and 6 tenths. But that is not reduced. 6 tenths is not reduced. So the whole number part stays the same, but we know that we can take 6 and divide it by 2 and 10 and divide it by 2. 6 divided by 2 is 3. 10 divided by 2 is 5. We get 3 and 3/5. All right. Let's look at number 4. Number 4 is 75 over 12. 75 over 12. I want you to do this one. I want you to do this one. And put your answer in the chat. And if you're not participating, I will be knocking you out of the class. Those of you that got bumped out, that's because you weren't participating. I'm hitting that remove from session button. I want to see participation. 75 over 12. I will give you a hint. This one you've got to reduce. You have to do some reducing at the end. And here's how you can write your answer. Let's say the answer was 1 1/2. So put a space. So write your whole number part, then put a space and put what your fractional part would be. So we're converting 75 over 12. Okay, need a few more of you. Okay, we're converting 75 over 12. want to see your answer in the chat. Let's go. Answers in your chat. All right, I'll start dropping y'all out again. Here we go. Gone. Okay, the correct answer is 6 1/4. Let's see how we did that. So we need to take 12 and divide it into 75. So when we take 75 divided by 12, we get 6.25. That means the whole number part is 6. So then I take 6 times 12, and we get 72. So 6 times 12 is 72. When we subtract, we get 3. So we have a remainder of 3. So 75/12 is 6. That's our whole number part. The denominator is 12, and the numerator is the remainder, which is 3. 3/12 is not reduced. We can divide the top by 3 and the bottom by 3, and we get 6. 3 divided by 3 is 1. 12 divided by 3 is 4. 6 1/4. All right. Let's skip down now to the next section. In the next section, we are adding mixed numbers, adding and subtracting. No, just adding. So number 1 on the new section down there, on the second page, we have 4 2/3 plus 4 1/6. Okay. When we are adding mixed numbers, we need to do the fractional part and the whole number part. Well, before we can do the fractional part, we've got to have a common denominator. So 4 2/3, I need to change so that it has the same denominator as the other mixed number. If I have a 3 and a 6 as my denominators, my common denominator is 6. So just like our rules for adding fractions, when we add those fractions, we have to have the same denominator, even when we're working with mixed numbers. So this 3, to turn it into 6, we would multiply by 2, take the top and multiply by 2, and we get 4. And then on the bottom, we already have sixths. So our fractional part, 4/6 and 1/6, gives us 5/6. And the whole number parts, 4 and 4, give us 8. So our answer is 8 and 5/6. 8 and 5/6. All right, number 2. We have 4 and 3/8 plus 9 and 5/16. Okay, I cannot add these fractional parts together yet because I do not have a common denominator. So I'm going to write 4 and 9, and my common denominator, if I have 8 and 16, my common denominator is 16. So this fraction didn't have to change. But this fraction, we've got to convert 3/8 into the equivalent fraction. And so when we take 8 and multiply it by 2, we get 16. So we have to take 3 and multiply it by 2 and get 6. Now we can add the fractional parts. 6/16 and 5/16 is 11/16. And the whole number parts, 9 and 4, give us 13. So we get 13 and 11/6. Okay. Number 3. On number 3, we have 4 and 2/3 plus 6 and 5/6. All right. We do not have a common denominator. I've got to have a common denominator before I can add the fractional parts. What is the common denominator for 3 and 6? The common denominator for 3 and 6. So we want the smallest number that 3 goes into and 6 goes into. Smallest number that 3 goes into and that 6 goes into. Okay, the common denominator is 6. So the bottom one, we don't need to change anything. It's already in 6. But for our 2/3, 3 changed into 6. We multiplied by 2. Multiply by 2 on the top, and we get 4/6. Okay. Now we can add the fractional parts. 4/6 and 5/6 is 9/6, and 4 and 6 is 10. Well, I see 2 problems, 2 issues. What's the first issue that you see? Because I cannot leave that as my answer. That is an incorrect answer because there are 2 things that need to be done. Okay, that is one of the things. Yes, ma'am. It can be reduced. Okay. All right, so let's do that. If we're going to reduce this, we divide by 3 and divide by 3. We get 10, and our fraction is 9 divided by 3 is 3, and 6 divided by 3 is 2. But now there's still another problem. We still have an issue. Correct. It's an improper fraction. 3/2 is an improper fraction. So what this really is, 3 halves is really 1 1/2. So if we take that 1 1/2 and add it to the 10, we get 11 1/2. So we have to change that improper fraction into a mixed number. All right, let's jump down to the next section where we have some subtraction problems, and let's look at number 1 in the subtraction area. 7 2/3. Okay, when we reduced this fraction and ended up with 3/2, we can't leave an improper fraction inside of a mixed number. So 3 halves is really 1 1/2. And so that then needs to be added back to the 10, which gives us 11 1/2. You cannot leave an improper fraction inside of a mixed number. You've got to change that. So we always have to reduce, and we always have to look to see if we have an improper fraction. Okay. So number 1 on the subtraction area, we got 7 2/3, and we're going to subtract 3 2/4. 7 2/3 minus 3 2/4. Okay. We need a common denominator. What is our common denominator for 3 and 4? What's the smallest number that 3 and 4 will go into? Smallest number that 3 and 4 will go into. So we're looking for our common denominator, and that's correct. The common denominator is 12. So now I need to look at how do I change 2/3 into 12ths? Well, I have to take the 3 and multiply it by 4 to get 12. Whatever I do on the bottom, I must do on the top, and I get 8 12ths. Okay. On the bottom, we took 4, turn it into 12, you multiply by 3. If you do that on the bottom, you must do that on the top. 2 times 3 is 6. Okay. Now we can do the fractional part. And you have to be careful when you're doing the problem in the stacked format. You've got to remember whether you're doing addition or, in this case, we're doing subtraction. So we have, with our fractional part, we have 8 12ths minus 6 12ths, which gives us 2 12ths. And we have 7 minus 3, which is 4. But the 2 12ths is not reduced. We can divide the top and bottom of this by 2, and we get 4, and 2 divided by 2 is 1. 12 divided by 2 is 6. So we get 4 1/6 as our answer. Okay, let's look at number 2 in that group. We have 9 2/5 minus 1 3/30. 9 2/5 minus 1 3/30. What is my common denominator? So we're looking for the smallest number that 5 and 30 go into. Okay, so yes, the correct answer, we're looking to change these into 30ths. So 2/5 changed into 30ths. To take 5 and turn it into 30, we multiply by 6. So if we do that on the bottom, we have to do that on the top and get 12. This is already 3/30ths, so we don't have to change it. And now we need to remember we're doing subtraction. So I've got 12/30ths minus 3/30ths. And if you take 3 from 12, you get 9. And 1 minus 9 minus 1 is 8. But the 9/30ths is not reduced. So we need to see that the number that goes into 9 and 30 is 3. So 9 divided by 3 is 3. 30 divided by 3 is 10. So the thing you need to remember about adding and subtracting mixed numbers. The whole number parts we don't need to worry about. It's the fractions that we got to make sure we have a common denominator. And the other thing is to be careful when you're doing subtraction and then not do all of this work over here and end up writing down, oh, that's 10 because I'm adding it together, and this is 15 because you got to look and make sure that you're doing addition or subtraction. All right, we got a lot today. Y'all had it kind of easy a little bit. All right, let's scroll down a little bit more. And now we've got multiplication. So when I have 2 1/4 times 2 1/5, when you are multiplying and dividing mixed numbers, you cannot just multiply the fractions and multiply the whole number parts. It doesn't work. We have to change these back into improper fractions. So 2 1/4 becomes 4 times 2 is 8, plus 1 is 9/4 times 5 times 2 is 10, plus 1 is 11/5. And just like we did last week, we need to look and see before we just straight multiply the tops and bottoms. Look to see if are any factors that are in common. 9 is 3 times 3. 11 is just 11 times 1. 4 is 2 times 2, but 5 is just 5 times 1. There is no common factor in the top and bottom. So on the top, we get 99, and on the bottom, we get 20. But we can't leave improper fractions as answers. So I have to do 20 into 99. So I need to do, on my calculator, 99 divided by 20. So when we do 99 divided by 20, we get 4.95. So that means 20 goes into 99 4 times. 4 times 20 is 80. So here I don't really need to use a calculator anymore because I can do 4 times 20 and get 80, and then subtract and get 19. So 99/20ths is 4 and 19/20ths. So the only part we're doing that's new is dealing with the mixed number and improper fraction part. That's the only thing new. Everything else is the same that we did for all last week and on Tuesday. Nothing new. Nothing new. Let's look at number 2 in this section. We have 2 1/2 times 2 2/3. 2 1/2 times 2 2/3. we have to change to improper fractions. 2 1/2, 2 times 2 is 4, plus 1 is 5 halves, times 3 times 2 is 6, plus 2 is 8 thirds. Now, before I multiply, I can do 40 over 6, but then I'm going to have to reduce. I see that I have a 2 in the bottom, and 8 has a 2 in it. It's 4 times 2. So the top is really 5 times 2 times 4. 5 times 2 times 4. The bottom is 2 times 3. The 2's divide out. Now we have 5 times 4 is 20 over 3. 20 over 3 is an improper fraction, so we need to take 3 and divide it into 20. You may see that that will go 6 times. If you don't need a calculator, don't waste the time. 6 times 3 is 18. We're left with 2. So this becomes 6 2/3. 6 2/3. Let's jump down to the next section where we're doing division. On number 1, we have 2 2/3. 2 2/3 divided by 3 1/2. Multiplying and dividing mixed numbers, you have to change them back to improper fractions. 3 times 2 is 6, plus 2 is 8 thirds, divided by 3 times 2 is 6, plus 1 is 7 halves. When we divide fractions, we keep, change, flip. On the top, we have 8 and 2. On the bottom, we have 3 and 7. There isn't any common factor on the top that would also be in the bottom, because 8 is 4 times 2. There aren't any 2's or 4's down in the bottom. There aren't any 3's or 7's up at the top. So we just do the multiplication. 8 times 2 is 16. 3 times 7 is 21. 16 over 21 is a proper fraction. We can leave it. 16 is 8 times 2. 21 is 3 times 7, just as we saw here. So that does not reduce. Okay, I'm going to jump to number 3. Number 3 is 4 1/5 divided by 2 7/10. 4 1/5 divided by 2 7/10. So the first fraction we need to convert to an improper fraction. 4 times 5 is 20, plus 1 is 21 over 5, divided by, then we need to take and change this to an improper fraction. 2 times 10 is 20, plus 7 is 27 over 10. When we're dividing fractions, we keep, change, flip. Okay? Now, I see that I have some common factors, because 21 is 3 times 7, 10 is 2 times 5. 27 is 9 times 3. So on the top, I'm going to write 3 times 7 times 2 times 5. There's my 21. There's my 10. Why take and multiply 21 times 10 and then 5 times 27 and then turn around and reduce out the common factor? Let's do it ahead of time. On the bottom, I have 5 times 9 times 3. So I can cross out the common factor of 5, the common factor of 3. on the top, I get 7 times 2 is 14 over 9. I saved myself a lot of work, but 14 over 9 is an improper fraction. So we need to come over here and divide 9 into 14. 9 will go into 14 once. When you subtract 9 from 14, you get 5. So we have 1 with a remainder of 5. 1 with a remainder of 5 ninths. 1 and 5 ninths. So it seems like it's a lot, but it's really not. We're doing the same thing that we have done. All we've added to it is that we have some improper fractions and some mixed numbers. So here is a sheet that I want you to work on. All right, the first one was the number 4 in multiplication, 3 1/3 times 1 4/10. When we have mixed numbers, we cannot multiply them. We have to change them back to improper fractions. 3 times 3 is 9, times 1 is 10 thirds, times 10 times 1 is 10, plus 4 is 14 tenths. Okay, well, right away I can see that I've got a 10 on the top and the bottom. So I have 10 times 14 and 3 times 10. The 3's divide out. We're left with 14 over 3. And that's an improper fraction. So we divide 3 into 14. It'll go 4 times. 4 times 3 is 12. So we have 4 with a remainder of 2. So there's our 4 2/3. On number 3 on the division, we cannot divide when we are working with mixed numbers. So 3 times 10 is 30, plus 1 is 31 tenths, divided by 4 times 2 is 8, plus 3 is 11 fourths. We're dividing, so we keep, change, flip, and I see that there's a 2 up here and a 2 down here. So on the top, I have 13 times 2 times 2. And on the bottom, I have 2 times 5 times 11. One of the 2's up here divides out with one of the 2's here. 13 times 2 is 26. 5 times 11 is 55. And you put 13, not 31. Oh, thank you. Thought something looked weird. So that should be 31. So at the top up here, we don't have 30. We don't have 13. We have 62. So I need to take 55 and divide it into 62. It will go once. And so we get 7. So this is 1 with a remainder of 7 55ths. Let's see, that looks better. All right, number 3. Number 3 on the multiplication, 2.5 times 3 4/5. When we're multiplying mixed numbers, we have to change to improper fractions. 2 times 2 is 4, plus 1 is 5 halves, times 5 times 3 is 15, plus 4 is 19 fourths. nope, fifths, 19 fifths. So the 5s are going to divide out. We're left with 19 over 2, and 2 will go into 19. 9 times 2 is 18. So we end up with 9 and 1/2. And then for the fractions, if we're going to take 5 and 2/8 and add 2 and 4/10, I'm going to do it with the stack method. I need a common denominator first. And so if I have 8 and 10, my common denominator is 40. If I don't see that right away, then I need to do my multiples chart of 8, my multiples chart of 10, and I would get down here to where there was a 40 in both of those. To change 8 into 40ths, I multiply 8 times 5, and then multiply the top here by 5. We get 10 40ths. To change 4/10 into 40ths, we multiply the 10 by 4. 10 times 4 is 40. Whatever we do on the bottom, we do on the top. 4 times 4 is 16. Then I add 5 and 2 and get 7. 10 and 16 is 26 40ths, but 26 40ths is not reduced. So that should be 7 and 26 40ths. The top and bottom, I know I can divide 2 into those. And so I get 7 and 26 divided by 2 is 13. 40 divided by 2 is 20. And so there's my 7 and 13 20ths. Okay. And then the last two where we were simplifying. So I had 1,115 divided by 125. I could go ahead and change that into a mixed number, but I'm going to do some simplifying first. I know 5 goes into both of those because they both end in 5. And so if numbers end in 5, then they are divisible by 5. So 1,115 divided by 5 is 23. Nope, that's not right. 1,115 divided by 5 is 223. And 125 divided by 5 is 25. All right. So we need to now take 25 and divide it into 223. So 223 divided by 25 is 8.92. So I know 25 goes into there 8 times. So I need to do 8 times 25. And I get 200. Subtract, and I get 23. So there's my whole number. There's my denominator. The remainder is 23. 8 and 23 25ths. And the last one to reduce was 28 over 40. I'm going to divide the top and bottom by 2 first. 28 divided by 2 is 14. 40 divided by 2 is 20. I can divide by 2 again. 14 divided by 2 is 7. 20 divided by 2 is 10. I get 7/10. All right. We are just about out of time. I do want to show you one of these videos. We did reading on Tuesday. Thursdays is our vocabulary and our grammar. I had a feeling we were going to run long on the math, but in Blackboard under today's folder, the vocabulary list is there. The vocabulary video is there for you to watch. I'm going to do one of these videos on the grammar, or maybe two.
If you liked this video, please click on the thumbs up. If you want to see more videos like this, please click on the subscribe button. And if you want to be notified when new videos are posted, please click the bell.